So here we have these container engines, right? Like Docker container engine, Podman, Cryo, Containerd, and all these things. So as and when the number of containers are increasing, the containers won't be able to manage themselves, right? That is why we have a manager who is there to manage all the containers. When I say manager, technically speaking, it is orchestrating the containers, right? So I have this orchestration tool which will be able to go and manage all these containers. So that is where Kubernetes comes into the picture. So Kubernetes is one of the container orchestration tool which manages the container engines. So far until Kubernetes version 1.22, Docker was a default container engine, but doesn't mean that it will manage only Docker. It also manages other container engines as well. But by default, Kubernetes were managing Docker container engine. From the latest version 1.24, 1.25 and things, they have removed the support for Docker and they have bought in the container engine container D. Okay, so now Kubernetes is a container orchestration tool. It is totally open source, developed in Go language, and there is no GUI by default. When I say GUI, it is an admin console that is not there by default. Now, as it is open source, what the other competitors or the other product-based companies are doing, like Amazon, Azure, Google, IBM, Red Hat, all these guys came into the picture. They took this Kubernetes platform and they started developing their own products. They started selling this as a service. For instance, AWS EKS, okay, Amazon Web Services, Elastic Kubernetes Service. So what Amazon did is they took this Kubernetes and they installed, they added everything in their own system. Okay, now what they claim is, okay, if you want, you come to us. Okay, if you want Kubernetes, you take the service from us. We will deliver that. The main advantage is we will take care of your cluster maintenance, upgrade, failures, and all these things. You no need to even manage your master nodes. Even the master nodes, everything means your control plane will be managed by us. You just work on the control nodes. I mean, you work on the worker nodes, play around with your deployment and all those things. Don't worry about all the nodes availability and everything. We will take care of it. So if you want Kubernetes as a service, either you can go to Amazon or Azure Kubernetes service or Google, wherein they call it as Google Kubernetes Engine, GKE. But Red Hat OpenShift, what Red Hat has done is, it is not that they are serving Kubernetes as a service, rather they created their own product. So who is this Red Hat? Who is into the play? Okay, Red Hat. So Red Hat is currently a IBM company. So in 2019, when the COVID was getting high, with the help of JP Morgan, the financial institution, IBM backed Red Hat. They just acquired Red Hat for, I mean, some several billions. Okay, and IBM is 100 years old company, and they have taken this Red Hat, and now Red Hat is part of IBM. And Red Hat was initially very well known for Red Hat Linux operating system. Based on the Linux open source flavor, they build on top of that, they build on several modules, security and all these things, and they released the product as Red Hat Linux operating system. They were so much successful so that 80% of the current corporates are having Red Hat Linux as their operating system everywhere, be it a media, be it Netflix or whoever it is, are including financial, healthcare, all these guys adapted to Red Hat Linux, and they call it as RHEL, that is Red Hat Enterprise Linux. Okay, this is everywhere now. Then they have Red Hat JBoss application server. Okay, so they didn't leave the application server as well. So application server in the sense which is well known for handling the transaction, that is an application server, acts as a middleware, right? It handles all the Java transactions and connect to the database. So we have IBM WebSphere application server, JBoss, open source is there, Tomcat, WebLogic, Glassfish. there are several application servers in the market, and we do have Red Hat JBoss application server as well. Then we have Red Hat OpenStack. Like Amazon Cloud or Azure Cloud, Red Hat has its own private cloud known as Red Hat OpenStack. Okay, then we have Red Hat virtualization, like virtual machines, right? Like VMware virtual machines. Red Hat has their own virtualization part. Then we have Red Hat OpenShift, what we are learning. Then we have Red Hat. These are the products of Red Hat, okay? Then we have Red Hat Ansible, which is another famous one. Then what else? Famous one I'm looking for. Cloud is there. This is there. Okay. I think these are the major one. What is there? Still, there are other products also into the line, but I have just posted the very famous one which are being used by most of the corporates. So Red Hat, what they have done is they are releasing products on all the cases. Okay, can be a DevOps tool or can be a cloud or can be an operating system or can be an automation tool. Everywhere they have their own product. Okay, similar way, Red Hat, what they have done is they have taken this Kubernetes platform, the open source platform. On top of that, they have built the product. And there are several things what Kubernetes as a open source do not have by default. Okay, but what Red Hat done is, as it is a product-based company and they have a set of team to build all these things, they created several things which are not as a native tool of Kubernetes. Rather, they provided everything, including GUI, networking, monitoring, everything. Okay, it is like the supermarkets nowadays, right? If you enter supermarket, they say that you no need to go anywhere, just enter inside. From your baby until your marriage and all these things, you have everything for your house to shop inside our supermarket, right? Can be vegetable, fruits, or clothing, furniture, electronics material, or vessels, whatever it is, come here and get it. Similar way, Red Hat OpenShift, what they are saying is, you no need to go for any third-party tools or third-party utilities when you are using this OpenShift. Rather, we have everything native support itself. That is very much famous, and Red Hat is well known for its security. So even that is very good at Red Hat OpenShift. And main thing is Red Hat has a GUI. OpenShift has a GUI, means a web console. So you will be able to create your objects like a pod, a node, a deployment, replica set, secrets, persistent volume, storage class, everything on one click. Okay. Whereas in Kubernetes, we are supposed to go and create the YAML, write all those things and do it. Rather, in OpenShift, you have it in the GUI itself. That is another big advantage. Now, if you ask me, do we use this web console in real time? Obviously, yes. Okay, most of the corporates are switching from open source Kubernetes to OpenShift. For example, the financial institution, including Citibank. Right? Recently, I got to know that Citi is totally moving towards Red Hat OpenShift. Right, and the several major clients are moving. The major reason is, practically speaking, when you have open source Kubernetes in your account, we need to have a strong set of team who can manage all these Kubernetes. If you have any issues, you need to have a strong team to fix those issues. Okay, the problem is you do not have any, Kubernetes or CNF, Cloud Native Foundation, who is managing this Kubernetes now, right? They do not have any obligation to support you because Kubernetes is open source. Worst case, you can go and raise a concern in the community and volunteers will come and respond. Whereas Red Hat, if you have any issues, Red Hat support team, the SRE engineers are readily available for you to help and fix the issues, whatever you have. So that is another biggest advantage what Red Hat carries, right? Everything they are doing, including the security part. So the vulnerabilities and everything is also being protected there. Okay, so OpenShift, in short, to summarize, OpenShift is a container orchestration tool. It's a Red Hat product. It is an enterprise version which has both free and also an enterprise edition. And Red Hat is there to support this, which includes any images, whatever you download, Red Hat is vouching for it. Okay, here I have given a main difference between Kubernetes and OpenShift. Okay, that is Kubernetes is open source. That's what we have been talking about, right? I've just given it in simple tabular format. Kubernetes is open source, but OpenShift is free at enterprise as well. So all the corporates will be having the enterprise one, which they can use it. And okay, coming back, what I was telling is, when it comes to this team, right? Kubernetes may have any issues, only the team used to support it. But here, as it is GUI, even if I have a lesser experienced person, if they have a very good experience across navigation and doing things easily, they can do it, which is happening in real time nowadays, right? They are recruiting guys who are with OpenShift with less experience as well. So they work on the GUI. In case of any issues, they can raise a Red Hat support ticket and go to them. And another example is, let's say you are upgrading Red Hat OpenShift from one version to another. When you upgrade it, if you get into any issues, you can't fix it. Rather, and rollback is not there. Rather, if you raise a support ticket, Red Hat team will come immediately and help to fix that issue. Okay. Coming back, Kubernetes no GUI. OpenShift I do have GUI. Okay. And here Kubernetes can be installed in bare metal, VM, and cloud. Similar way, OpenShift also can be installed in bare metal, VM, and cloud. But if you take this Amazon EKS, Azure, and all these things, right? Only if your environment is having AWS, then I can go for AWS Kubernetes service. Only if my platform is having Azure, then I can opt for that service. That is one. That is one thing is there. But OpenShift, you can install it on bare metal. When I say bare metal, nothing but servers, right? Even if your servers are in on premises, means you are having a data center, no cloud, no problem. You can download the OpenShift software and install that, subscribe to the enterprise edition and start working on it. And virtualization and also cloud. Okay. During this COVID only, what Red Hat did is they made a deal with Amazon, Azure, Google, IBM, and everyone, stating that, hey, please allow me to have OpenShift getting installed on your respective clouds. In case of any issues, we'll be there to support. So they made a deal, and now OpenShift is available in all these cloud providers as well. We can install over there as well. Then with respect to network, there is no native network provider. If you all remember, when we started this Kubernetes, I was referring to this that we do not have a network provider. Rather, we were in a position to install the third-party network providers. Okay, I'll repeat again, guys. So for an example, let's say there are two pods, or I have two containers, or there are pods running on different nodes. For all these pods and containers to communicate each other, I need to have a network provider. I need to have a network, only then I'll be able to do that. For this, with respect to Kubernetes do not have a native network providers. Instead, what they do is they go for a third-party network providers like Calico, Flannel, Rumeno, VNet, and there are several third-party network providers who support Kubernetes. So I have to install those third-party network providers. Wherein, if you come to Red Hat says that, hey, I have my own SDN, means software defined network. There are three different network SDN what we provide. They are OpenShift SDN, OVN, Kubernetes, and Courier. These are the three network providers what I have as a native support itself. Then logging, monitoring, no native support in Kubernetes. Okay. If you all remember during HPA, that is horizontal pod auto scaling concept, when we run kubectl top nodes or kubectl top pods, the metrics will not work by default. So I told you that we have to install a metric server. Means by default, Kubernetes do not have an option to get all the metrics. Okay, by default, that is not available. Instead, we have to go and install a third party to get the metrics. At least even in Windows, I have task manager, right? Even in Windows, I have task manager, which will tell me the CPU, memory, storage, how my network is working, how my Wi-Fi is working, and all these things it will give, right? But In Kubernetes, I do not have it and I have to go for a third party. Wherein OpenShift, by default, they have Prometheus. Okay, Prometheus is a monitoring tool which collects the metrics, a open source one. So OpenShift has this by default. Okay, so it will be able to collect metrics. Then no native registry for Kubernetes. If you all remember, when we install Kubernetes and all of our container images will be still coming from Docker Hub or some other thing, right? Kubernetes do not have a native registry. So what is registry? A place where I have all my container images stored. So Kubernetes does not have. But what OpenShift says is, hey, no worries, I have my own native registry, Red Hat Container Registry, Quay.io. These are the registries being supported and owned by Red Hat itself. For instance, for Quay.io, Red Hat is sponsoring. Red Hat's own registry is Red Hat Container Registry. The advantage is if you have subscribed and if you are entitled to get the container images from these registries, we can assure you that there won't be any issues. Or Red Hat says that if there is any issues, we have specified the health index, whether it is A, whether it is B, whether it is C, or whether it is D. If it is A, it is well and good. If it is B, it has few vulnerabilities. If it is C, hey, 50% issues are still there. D means we are not recommending it. Okay. So they are scanning the images whichever is being uploaded and they are doing. And there are several images which Red Hat is scanning and they are telling that, hey, there is no issues in this, you can take it. In case if you have any issues with the container images, we are there to support. Okay, that is another advantage of using the native of Red Hat itself. Then storage class. Okay, storage class, we have to create this manually, right? I mean, means nothing but an object. Storage class is an object to support the persistent volume. Right? Even if you remember morning, I was copy pasting the YAML file of storage class, right? For an example, let me show that real quick. So, morning, what we were doing is Kubernetes.io storage class. So if you see here, for AWS, we have AWS EBS. So I have to copy this YAML file and paste it. Okay. And if it is GCP, I have to click on this. I'll have this YAML. I have to copy, paste, and create. So we are in a position to create these YAMLs and do it. Okay. Whereas what OpenShift says is, okay, you no need to create all these things. Okay. If you have installed OpenShift on AWS, I'll create a storage class supporting AWS automatically. If you are installing OpenShift on Azure, I will create the storage class which will support the Azure automatically. If you are installing OpenShift on Google Cloud Platform, I will have the storage class created automatically. Storage class object created automatically supporting Google Cloud Platform. That is another one what we have. Then the last one is the community support. As I already said, if you have any issues while using Kubernetes, you can raise the concern in community support, but you do not, they are not obligated to it. But here you have the Red Hat support who will be there to support you. Okay. And then the products. Initially, we are talking about this, right? Kubernetes has two products. One is single node cluster, that is comes as a package name called Minikube, and the other one is multi-node cluster. Guys, one more thing. Whatever I am discussing, things are available in this topic. Okay, don't worry. Everything they have given in detail, whatever I'm talking. So I'm taking the main crux of it and I'm talking about. Okay. So that I mean, this will help you from interview perspective as well. Instead of reading the whole PDF, this also can be checked. But everything what I am handling is within the PDF also. Okay, and other things from real-time discussions. Now, so Kubernetes has this Minikube that a single node cluster means this package can be installed on a single node, single server, right? The problem is if that is a standalone, right? If that server goes down, your applications will be down. That is why in real time, we always go with multi-node cluster. This is a document which I have shared today as well, right? And tomorrow we'll be sharing as a blog. If you go to CubenSquare.com/blog, you can find the installation video there as well. So all of you can set up this week, as I said, please make sure that each one of you complete the multi-node cluster also. Okay, multi-node cluster in the sense I can have one control plane and multiple worker nodes, right? These are the two products what we have with Kubernetes. In OpenShift, I have around 5 different products. Red Hat OpenShift Container Platform, and we refer it as OCP. Okay, this is the topmost one. This is the one what we are also going to use it. What we'll be learning here as well throughout the class and the course. OCP, this particular package can be used and installed on a bare metal virtualization or even cloud providers. It can be installed everywhere. You have the overall control. You decide when you wanted to upgrade. Okay, you maintain the nodes. You do everything. It is very similar to what we did in GCP. What we did in GCP, we created the virtual machines, we installed Kubernetes, we made the setup one by one. Similar way, here at that OpenShift container platform, we create the nodes, we manage the nodes, we manage OpenShift cluster. When there is an upgrade, we take care of it. Everything can be done by us. And it is a fully loaded package. This has everything, means Red Hat OpenShift container platform is this. You see this? Okay, this can be installed on a physical machine, virtual machine, private cloud, public cloud, managed cloud like Azure, AWS, IBM, and Red Hat. And this has a Red Hat Enterprise Linux and RHEL Core OS. I'll talk about Core OS in a while. Then container runtime, Kubernetes, all cluster services, what we discussed. Then all other platform services, application services, developer. Because in GUI you have all these things. We just go to OpenShift console, we can keep deploying services over there easily. Okay, so Red Hat OpenShift container platform is a whole package. It has everything. Red Hat OpenShift dedicated cannot be installed in bare metal. It can be installed only on virtual machines and cloud. And one more thing, what they're saying is Red Hat is managing this. Okay, Red Hat says that we are there to manage your cluster. The only control what you will have is you can just decide when you wanted to upgrade the cluster. That's it. Okay, there is a new cluster being released. You decide when you wanted to upgrade that. Until then, I'll be waiting. Okay, that is dedicated. But and it cannot be installed on bare metal, only on cloud and virtualization. And the next one is Red Hat OpenShift Online. This is can be installed only on cloud, totally managed by Red Hat. Okay, you don't have any control. Means about the management, your cluster upgrade, and all these things. Red Hat is going to manage. You can just deploy the applications and play around. That's all. But you cannot administer the Red Hat control plane or upgrade options. Everything is taken care by Red Hat itself. Then Red Hat OpenShift Kubernetes engine, which is nothing but a subset. Okay, it is nothing but a small subset. If you see this here, Red Hat OpenShift Kubernetes engine. This is just a subset, not the overall services, rather a small subset of OpenShift it is taking care. And the last one is like Minikube. Red Hat code ready containers is like your Minikube, which we don't use in real time. Means in production, we don't use that. That is just for research purpose, or you can install it in your own machine. That's it. Because it is also sort of single node cluster. If it goes down, everything is down. That's all. So Red Hat code ready containers are sort of single node clusters, which we do not use it. Okay, so these are the different OpenShift products. And as I said, we will be learning throughout the course about OCP, Red Hat OpenShift Container Platform. And every objects, whatever we learned in Kubernetes, right? The same thing we'll be learning here also. Like pod, deployment, daemon set, replica set, namespace, node, PV, PVC, SC, all these things. Whatever we learned in Kubernetes, the same thing we'll be learning in OpenShift also. Okay, there will be additional things added, but we'll be talking about later. This is just to give a feel that, hey, it's not that we are going to learn something totally new. Rather, it is very similar to Kubernetes, but with additional features. One more main thing, what you can note in this diagram is, I have my hardware. On top of the hardware, I am installing Linux or Windows, whatever it is. Then I have my container engine like Docker or containerd, whatever. Then I bring in Kubernetes and install it, right? This is the sequence what we install Kubernetes, right? I have a hardware, then I install the operating system. Then on top of that, I have the container engine. What is container engine? Container engine is a piece of software to create and manage the containers, right? And I have multiple container engines market. So here I've represented Docker and containerd. On top of that, Kubernetes. This is what we learned in Kubernetes. And coming to this, here we also know that container engine, we have, as I said, we have Docker, CRI-O, containerd, Rocket, Podman, and things, right? What these guys have done is, okay, that is what OpenShift has done is, they have considered the container engine as CRI-O. By default, now as you know, from 1.24, Kubernetes is considering the container engine as container D. Similar way, here for OpenShift, here they are considering the container engine as CRI-O container engine. CRI-O is open source container engine. It is OCI compliant as well. Okay, OCI compliant. CRI-O is a container open source container engine. It is OCI compliant. Okay, OCI in the sense open. Forgot the name. Yeah. Open Container Initiative. Container Initiative. Okay. So whoever is creating a container engine, if they get OCI compliant, it means that they have followed the standard set by OCI, means Open Container Initiative, which is good for us. So CRI-O is one such thing. So OpenShift have chosen, Red Hat has chosen CRI-O as a stuff. So here I have a Red Hat. Then until 4.0 or 4.3 version, they were having Red Hat Enterprise Linux, okay, as their operating system. On top of that, they had the container engine CRI-O. Then we have Red Hat OpenShift. Then we create the pods. From Red Hat OpenShift 4.0 or 4.4, and now it is 4.6, they started bringing in the operating system called RHEL Core OS. Okay, they started bringing in the operating system called RHEL Core OS. This is an operating system, but it is lightweight operating system. Okay, designed to handle container-based application. This is specifically designed to manage the container-based applications. Okay, and initially it was separate, and Red Hat what they did is they acquired this core OS and they named as RHEL Core OS. The OS itself is as a container image. That is the biggest thing. Okay, so it has secure more security as it is immutable container image. Okay, the entire operating system itself is as a container image. It is totally secure. Okay, it is immutable. You cannot go and penetrate and do everything whatever you can, what you do in Red Hat Linux. So here it is totally lightweight because they designed this. See, normally all the containers are lightweight, right? We all know that. The reason why all the corporates and product-based companies are moving towards containers are they are totally lightweight. Similar way, This RHEL core OS is also totally lightweight and they are designed to handle the container based applications alone. Okay. So they Red Hat started adopting this RHEL core OS. Then we have the container engine Creo, then Red Hat OpenShift. Now the advantage of having this is one is main thing is security. You can't penetrate. Okay, and it is totally immutable. Another good thing is when you have an upgrade for OpenShift or when you have an upgrade for the OS, as a OpenShift administrator or OpenShift specialist, we can take over the upgrade. Whereas if it is Red Hat Linux, right, we used to engage the Linux operating system team. We had to tell them that, hey, can you go and upgrade my Red Hat Linux from 8 to 9 or 7 to 8 like that. And whenever there is an update, they have to go and update the packages as well. But when it comes to RHEL Core OS, as RHEL Core OS itself is acting as a container image, Red Hat is taking care of the update for that as well. When we run the update option in OpenShift, it will take care of updates for RHEL Core OS also. And the excellent thing about OpenShift is, as it has a web console, right, GUI, updates are pretty straightforward. You just go, click on the drop down, select whatever version you want, click on update, and you're done. That's all. One click button, update is like our mobiles, right? You update it and you just go. It will take care of your OpenShift update along with the RHEL Core OS update as well. That is good thing about this. Okay, so in this diagram, what you see is until version 4, okay, until version 4, the way it was is they were saying that, hey, OpenShift master, that is the control plane, mandatorily should have RHEL Core OS. But your worker nodes, no problem. You can use Red Hat Linux as an operating system, that is totally fine. But control plane, mandatorily RHEL Core OS. And after nowadays, right, with the latest one, they started telling that, hey, no more from version 4.4, I think so, 4.6. Okay. What they started telling is no more Red Hat Linux. It can be your master or worker node. Every node should have RHEL Core OS as a operating system. They have told us. Okay, now we are going with RHEL Core OS overall. And this installation, right? One more thing in that is OpenShift installation. We all did Kubernetes installation, right? How we did? As I told you, we create 3 GCP instance, right? We create 3 GCP instance. That is, if you all remember the thing, we'll just go to Kubernetes installation. We have this setup here, right? We all went to this CubenSquare GitHub and we use this setup, right? This is a one what initially were having issues actually, right? Then now currently it is fixed. So we opened the installation steps, says create 3 GCP instance. So we created the instances, then we ran each and every command to set up this, right? This is for the Kubernetes installation. Similar way, okay, we took care of everything, right? We created the node. We just went and we created all the nodes on our own, right? We did everything manually. Similar way, here also what they are saying is you have a concept called pre-existing infrastructure. Okay, whether it is bare metal, Red Hat virtualization, or cloud, you take the control of everything. You select the node which you want, you select how much CPU, memory, then you install it. That is pre-existing infrastructure. There, until version 4, you can have your master with RHEL Core OS and Red Hat Linux on the worker nodes, which is totally fine. But if you are going for full stack automation, what is automation? There is no need of any manual interruption, right? You just give all the instructions to the OpenShift installer and it will just go and hit install across all the things. But the thing is, if you go for full stack automation, irrespective of your OpenShift version, all the nodes will be having RHEL Core OS. There is no concept of Red Hat Linux. Everything will be having RHEL Core OS on. Okay, that is on the full stack automation. Okay, and the OpenShift master. Hope all of you remember this, right? It is very similar to Kubernetes. So we have the API server, we have HCD, scheduler, controller, kubelet. All these things very similar to Kubernetes. API server, if you all remember, this acts as the front end gateway to get all the requests. Whenever we run any kubectl command, right? Kubectl get pods, kubectl create deployment, kubectl create secret, anything, whatever we run, all the commands will be taken in by the API server. API server will connect to scheduler, which will schedule the pods across nodes. Controller will take care of the current state of your pod. HCD is a database to store your objects. Kubelets is an agent across all the nodes, which connects between your master and worker node. Right? The same explanations and the same components what we saw in Kubernetes. Along with this, we will have another concept called OAuth, which we'll talk about in the next chapter. Okay, OAuth, OpenShift authentication. We'll talk about that later. And along with that, the main thing what we have with this OpenShift is the same Kubernetes, high availability, right? In case of one cluster crashes, no problem. I can spin up another cluster immediately as all the data will be available in HCD cluster, right? HCD is a database which stores all the objects information, right? In case if your cluster goes down, you will be able to make it up with this HCD immediately. Then as I said, it is lightweight operating system. Whatever I explained, it will be available here. Then load balancer. Load balancing, as the name implies, it's a when the requests are coming in, how am I going to balance the load? So we have this three type of load balancers. Okay, one is external load balancer, which manages the OpenShift API. That is, whenever the requests are coming in to the API server, right, to this OpenShift API, there is a load balancer. We call it as external load balancer. So all the requests coming in will be done by them. Then we have, we'll talk about this later. Okay. Then we have this HA proxy load balancer, which is there to access the application. That is, if I go to a browser and access the application, okay, something www. Sorry, some CubenSquare.com or something. If I access the application, how am I able to access my application in OpenShift, which is running in OpenShift? That is through HA proxy load balancer. And the other one is internal load balancer, which uses net filter. Means within the cluster, all the communications, right? All the services are talking to each other with the internal load balancer, which uses net filter rules. Okay, so we have three different types of load balancers. I'll put this as well here. Load balancers. We have so the first one is external load balancer, which is manages OpenShift API. The other one is also external load balancer, but this one for the external access to applications, and the last one is internal. It is for internal access to application. These are the three different load balancers we have. And then we have automatic scaling, which is available in Kubernetes. The same stuff we have it over here as well, auto scaling, which includes your pod and also your node. Logging and monitoring, as I said, by default, Kubernetes do not have one, but OpenShift has its Prometheus, which collects the metrics. Service discovery, this is available in Red Hat, it is available in Kubernetes as well, which is nothing but whenever you are accessing the application through service, how the service object is connecting to the pod, and we're able to fetch the details. I'll repeat. We all know that we have pod. Inside the pod, we have the application, right? And we expose that particular pod using service, right? Now, how those communications are happening in the background, that is with the help of service discovery. We'll talk about in that in the upcoming chapters. Okay, then storage, as I said, we have all these storage options as well here, the storage class and things. You'll be able to have the persistent storage or to the cloud and all these things. Was it? Yeah. You can see that pod is exposed to service, and then here comes, it is also a load balancer. We called as route. Okay, it comes outside. Okay, so as he said, yeah, on top of that we get it. Okay, on top of your service, we have this load balancer which will manage the incoming request. We'll talk about that in in sixth chapter or fifth chapter, which will talk about external application access. So to answer your question, yes, above services we have this.
And what about this internal load balancer, where it will be placed? If we are
We
using
don't need to
services
create.
and
See,
things
by
like
default, these gets created. Okay, by default, these gets created. For instance, if you don't want to access your application externally from the browser, you
your
just
voice is
want
low.
your
I'm sorry.
application. Yeah. Now is it fine?
And now it's clear. Yeah.
Yeah. So if you want your application to be accessible from browser, then you go for the external load balancers. But if you don't want your application to be accessed from browser, rather let's say it's a database, you want your database to be accessed only within the cluster by some other application, then you by default it goes for internal load balancer, which is we call it as cluster IP. Got
Okay.
it? That is internal. You can access that application within the cluster alone. You can't access from the browser. Clear?
So
Yeah.
correct me if I'm wrong. Yeah.
One example on that is, yeah, one example might be, let's say Book My Show. This browser application, let's say this is running on Python or Java, whatever it is. So this particular one, I'll put it as a external service. Okay, means it is my load balancer node port, or I'll put it even outside that. Okay, this one I'm able to access from outside. But when I book the movie ticket, let's say I'm booking the movie ticket for Tuniva. When I book that, the tickets are getting stored in a database, right? And that database we cannot access. That database is accessible only to this Java application. So that database will put it in internal. This Java application will put it external. Got it?
Nothing comes. So correct me if I'm wrong. So when I'm hitting an application on the browser, okay, so that will go to the load balancer, as you, I mean, like HA proxy, and after that node port, and then the communication. I mean, after that it will go to the cluster IP and the target port. And this is how it gets flows. Just wanted to understand.
Correct. See, this is a flow. I'll when during a particular thing, I'll just go ahead and come to this. Okay. Don't worry. I'll show some examples on. For example, I'll take the example of CubenSquare. If I hit that, how it comes to load balancer, how they configure. I'll give an example so that you can correlate. Got it?
Okay.
Yeah. But your understanding is right. Whatever you said right now is correct. That's the one.
Thank you.
Yeah. Okay, then application management, we have a concept called S2I. Okay, guys, first chapter is all about theory. Okay, first chapter in OpenShift is full and full theory, unfortunately. Okay, so that's why if I go with the PDF alone, everyone will sleep. That's why I have just cut short everything into PPT and I'm explaining everything. Okay, here we have a concept called S2I, source to image. Good thing about this source to images, I am helping the developers. I'm telling the developers that, hey, previously, if you wanted to develop a customized image, you have to write a Docker file. Now I have a tool called S2I, okay, source to image. You just take your Java code, Python code, .NET or whatever it is, put that into the S2I. I will convert that code into a container image and give it. That's it. Okay, so I no need to sit and write the entire Docker file. S2I will take care of that. That too is there, which has The runtime support like Python, Ruby, Java, Node.js, and database message, everything it has. Okay, the sort of compilers. Okay, it already has it. Cluster extensibility in the sense, as I already told you, Red Hat OpenShift on top of Kubernetes, whatever API resources currently they have, right? Pod, deployment, replica set, operator, namespace, and all these things. On top of that, they extend the API objects with additional features and they're releasing that. Okay, that is the extensibility what we have with Red Hat OpenShift. Okay, several features what is not available with Kubernetes, OpenShift is having. Okay, this is the one which I told you guys. 1 minute. The control plane is similar to what we saw in Kubernetes, right? We have CRI-O, kubelet, etcd, scheduler, control manager, API server, everything what we saw there. Along with that, we have this OpenShift OAuth. OpenShift OAuth is nothing but let's say Victor wants access to the cluster. So what he'll do is I will create the username and password for Victor. I'll give proper role and Victor will get authenticated through OpenShift OAuth. Okay. OAuth will stand outside and see whoever is coming in. If you don't provide proper credentials, it will not allow you inside. That is the role of OAuth. So this OpenShift OAuth is there, which we'll be discussing in chapter 3. Okay. And then there's a default storage class, which I already covered.
Sorry,
by default.
I couldn't
Sorry?
get what is that auth. I couldn't get what is auth. Can you just repeat?
Authentication for access to your cluster. Okay. By now, by default, it is kubeadmin user ID alone. But if I wanted to have access created for Victor, Anand, Boaz, and everyone, I can create the users. I can assign roles to them. Developer role to Boaz, admin role to Victor, and viewer role to Anand. Like that, I'll be able to do it. But when I log in and create it, who is going to authenticate me? Who will tell that I am authorized to enter inside? That will be taken care by OAuth. Got it?
Okay, it is like role-based
We
access.
will be creating users and we'll be creating we'll be mapping that to roles. We will modify OAuth and everything in chapter 3.
Okay, yeah, got it.
And this one also I told you about the AWS or Azure or whatever it is. The storage classes are created automatically. We no need to go and create manually. Everything is, if you opt your OpenShift to be installed in AWS, it is taken care automatically. Okay, I no need to sit and create. Okay, then few quiz. When you have time, we just go through that, guys. The final one is cluster operators. See, operators are nothing but to avoid the manual works, we have these operators. Operators are nothing but then objects in Kubernetes and also OpenShift. Okay, objects. These are in Kubernetes also we have operators. OpenShift also we have operators. Okay, to avoid manual efforts, steps, we have operators. Whatever is being done by humans as a mundane task, manual repeated activities, all those things are automated and given as an operator. Let's say an example, database. I'm asking you to install DB, configure backup policy, configure rotation policy, etc., etc. All these things I'm saying. If I don't have an operator, you have to do all these things manually. Install first, then configure first, then configure the backup and everything. But if you have an operator, it comes as a package. Okay, for example, if you opt for MySQL operator, MySQL operator, the package will get installed and all the configurations related to MySQL will also get installed. You can go and modify whatever you want. Okay, but the default templates will be readily available. You just need to click on in GUI itself, we can install. Okay, in GUI, just choose which operator, click on that, the package will get installed. And later you can go and modify the parameters. That's it. You no need to write any YAML. You no need to sit and provide so much of details. Rather, the entire template and the configurations are readily available. Not just for MySQL, can be database. For instance, I have this uh, Operator Hub. Operator Hub is an open source one. Okay, this is not Red Hat stuff. Operator Hub. In Operator Hub, you can go and see here. These are the categories for machine learning, application runtime, big data, cloud provider, database. For everything, I have an operator. So if I want, let's say, Cassandra database, okay, manage full life cycle of Cassandra cluster. I just need to install this. That's all. If I install this operator in my machine, this will have all the options built in Instra cluster to allow creating and managing Cassandra clusters. Right? One simple example. Let's say I have a Kubernetes cluster operator. Example. If I have a Kubernetes cluster operator and if I install that, that itself will install master worker node, attach the worker node, configure everything and give it. That's all. I no need to go and sit and do everything. Operator will take care of everything. Similar ways, this Cassandra database, it will take care of all the things, whatever you want. There is no need of any manual stuff, scaling, your monitoring, or whatever you wanted to, including your stateful segments, your persistent volume, configure the persistent volume. Everything is being set automatically. This can be done using available operators. And you can see for across all the categories you have, can be a storage, can be monitoring tools. Even if you want a monitoring tool, don't sit and waste time in writing all the YAML and configuring everything. Rather, you have as a package. Just go and install it. That's all. Okay, everything is available. See here, if you use Datadog as a monitoring tool, Datadog is a monitoring tool. If you use Datadog operator, this will take care of installing Datadog agent, getting the Datadog metrics, and Datadog monitor. Everything done. No need to sit and manually do things. No. Yeah, example applications, not just applications. That's what I'm saying across all the platforms. So if you want a database, go for database operators. If you want a web server, go for web server operator. If you want let's consider this way. Any software, whatever you wanted to deploy, you just come to the operators, search for that software, application, database, web server, networking, monitoring, logging, everything, be it any category. Come here, search for the respective operator, install it. One other layman terms, let's say I'll put it this way. Let's say Netflix application, a very layman example, Netflix software or Microsoft, I'll take Microsoft Word. Microsoft Word software application. Instead of installing that separately, I can go and search for Microsoft Word operator. That will take care of the entire package installation. Got it? So not just for application, for all these categories, whatever software is being mapped for everything, I have an operator. Got it? Got it, Victor? Able to understand me?
Yeah, it's clear.
Okay. Yeah. So the main thing is purpose of operator is usually to automate tasks that human administrator would perform to deploy, update, and manage applications. Okay. The purpose of an operator is usually to automate tasks that a human administrator would perform to deploy, update, and manage applications. The entire life cycle of an application is kept inside this operator. That's all. Okay. Another very layman example. I'll put it this way: marriage, right? When you have a marriage, if you are going to take everything and do it individually, you have to go and connect with all the decoration people, then your vehicle decorations, then your food, your vendor, catering vendor, everyone you have to catch separately, right? But if you go and catch marriage brokers, right? I mean the event management team, they will take care of everything, right? Your food, your decoration, then your card printing, and all these things, your speakers, DJ and everything, whole package, they will take care of all those things, right? The event management team. Similar ways are operated. That's it. Put it that way. Clear, Victor and others? And now if you feel that, hey, I wanted to create my own operator. See, note this. It is not just open source operators, okay? Red Hat also has this Red Hat marketplace. more minutes, guys. 6. Okay, Redhat Marketplace. Okay. Red Hat Marketplace, here we have all sort of Red Hat products under different categories. Okay, like categories of database, data sets, developer tools, feature product, big data, application, all the categories we have, all the different operators. But thing is, it is managed by Red Hat and you have to purchase these operators. The good thing is, if you have any issues with these operators, Red Hat is there to support. At the same time, this is open source. This is Red Hat's product. Okay. And here, if you feel that, hey, I wanted to create my own operators, yes, I can do that. It can be in any language as well. You can create the operators in any languages. At the end, you have a concept called operator framework. With that operator framework open source toolkit, after writing your operator, what you can do is you can build, test, and package that as an operator. I'll repeat again. So you can develop your own operator, which is not required, guys, because as I told you, you saw that, right? In all categories, you have predefined operators are there. Then why are you going to waste your time? You already have it. But still, if you feel that I want a custom operator, if you know programming language, you can go and define, you can create your own operator. Then finally, to build, test, and package the operator, use operator frameworks. Okay, and this is also giving couple of components actually to help this. One is operator software development kit and operator lifecycle manager. Okay, so operator SDK, this development kit is nothing but it provides a set of Golang libraries and source code examples that implement common patterns. See, to make your life easier to create these operators, they are giving this development kit. With this, okay, make your custom operators whatever you want. Then they have this OLM, operator lifecycle management. This helps in managing the deployment, resource utilization, updates, deletion of operator itself. Okay, when you have multiple operators, to manage those operators, we have this OLM. Because operator also needs updates, right? Whenever there is a new update, operators should also get updated. So this is taken care by operator lifecycle managers, where we have this operator hub and Red Hat marketplace as well. And Red Hat is known for several predefined operators. That's the main thing. See, Kubernetes also has operators, but is Red Hat, right? Just to support all the cluster management itself, they have multiple predefined operators, which includes authentication operator, cloud credential operator, cluster autoscaler, console, DNS, image registry, ingress, monitoring network, several operators they have it. So when we set up the OpenShift cluster itself, these default operators are getting installed. These operators are taking care of their authentication, networking, DNS, monitoring, console, registry. All these setup are being automatically taken care of by this operator. Why? What is the use of this? See, if as these operators are readily available, we as an administrator no need to go and configure all these things manually. Everything is taken care by this operator. The entire setup is ready. You just need to go start having your food in the hotel. That's all. You don't need to go and prepare everything. Everything is readily available. So Red Hat by default has multiple operators. These are very few operators what you're seeing. So you don't have these operators in Kubernetes by default. OpenShift, they do have. Okay, in chapter 8, we will see how to install an operator. But in exam, operator is not available actually. Only in advanced OpenShift we have operators. But in this exam, we do not have this operators question.